some more topics regarding the QoS, VPN, attack defense, URL filtering, etc. First of all, let's have a look what we are doing for the bandwidth control in Houston NG firewall. In this chapter, I'm going to share the basic concept of the QoS pipe, what we designed for QoS control. And the second part will be the configuration for the QoS pipe and also the actions. So what is pipe? So Houston, we developed the pipe concept to provide the different priority for different traffic, especially to ensure those normal transmission of the critical business traffic and control the traffic for those unimportant service. We develop the QoS by adding the pipe concept, and by configuring the pipe, we can classify the traffic using the pipe matching condition and control the traffic that cross the pipes according to the actions that defined for the pipe. And for all the traffic crossing the device, they will flow into those virtual pipes according to the matching condition of the traffic. If the traffic do not match with any of the condition, it will flow into the default pipe that already predefined in the system. As you can see from this slide, for the pipe and also the QoS control, we separate into two levels: level 1 control and the level 2 control. In this case, you can do the fine-grained control for both users and applications. Under each of the level, the traffic control is classified by the pipes. We support 4-layer pipe nesting under each level. As you can see, for the level 1 control, we can do layer 1, layer 2, layer 3, and layer 4, which is 4-layer pipe nesting to do the fine-grained control. And for the layer 2 control, is the same. We support 4-layer pipe nesting for both layer 1 and layer 2 control. And you can use layer 1 control to control for specific users and layer 2 control for the specific applications, or vice versa. Once the traffic flows into the device, if the device enabled with the QoS function, first of all, it will flow into the level 1 control and classified into different pipes according to the matching conditions and the actions. And then it will flow to the level 2 control as well. By default, the level 2 control is disabled. You can configure for both level 1 and level 2 as needed. For the pipe, as I mentioned, this is a virtual concept which contains two parts of the configurations. One we call traffic matching conditions, which is used to classify for different traffic based on the matchings of the conditions. And the second part will be the actions, So in this case, it's quite similar comparing with the policy. So pipe control is similar like the policy control, but this is dedicated policy control for the traffic, for the bandwidth. So conditions and actions, those are the major components for each of the pipe. You can add multiple matching conditions to one single pipe, and the logical relation between those conditions is all. So once the traffic flows into the pipe, it will try to match with each of the conditions. As long as there is any condition matched, so the traffic will flow into this pipe. If you have multiple pipes that configured with same matching conditions, so the matching sequence will be from the top to the bottom, which is also similar like the policy matching sequence, right? It's from the top of the list to the bottom, from the top of the list to the bottom. That is the matching sequence for the pipe. And also, as I mentioned, for the action control, we support 3 different QoS modes for the root pipe. So that is a QoS mode action to manage the traffic. By default, the device will working under the ship mode. So which the system will limit the data transmission rate and also smoothly forward the traffic. The second one will be the police mode. That means the traffic will strictly drop the traffic as long as the traffic exceeds the bandwidth limit. And the last QoS mode will be monitor mode. So in this mode, the system will only monitor for the matched traffic and also do the statistics analysis. It will not control for the traffic. So this mode is the default mode for the default pipe. So the default pipe will only monitor the traffic, but do not do any shape or police for the bandwidth. So that is the overall QoS mode for the root pipe. And this is actually the matching condition for each of the pipe, which including the source, the destination information, the users, the service, the applications. So in this case, those are same as the policy. And you can also control based on the URL categories or based on URL. So in this case, we can control the bandwidth for the specific URL category or URLs. And for each of the pipe, you can also configure for the specific action, for the bi-directional traffic. We can set for both forward and backward for bi-directional control. So forward is the traffic from the source to the destination. As we can see here, the matching condition, we have source, we have destination. So from source to destination, so the traffic direction is forward, and backward is from the destination to the source. So in this case, we can do bi-directional control for the bandwidth traffic, And you can configure for both of the forward and backward. And here is also some bandwidth control. You can do the bandwidth reserve. You can reserve the bandwidth for the pipe, and also limit the bandwidth per user or based on the user IP, all applications. Here is some example how to configure how to configure the root pipe and also the subpipe. First of all, you need to configure a root pipe. And then under each of the pipe, as I mentioned, you need to set for the matching condition and also for the action. For action, you have both forward and backward direction. Both forward and backward direction. And after you configure the root pipe, for bidirectional control, you can also add the subpipe under this root pipe. So we support maximum 4 layers nesting for the pipe. And after the level 1 control, you can also enable the level 2 control. This is one example. So how the QoS works in our NG firewall. So we have some requirements from the customer. So the first requirement will be the bandwidth control based on IP or based on the user group. So if the total link bandwidth is 100 mega, and you need to assure the different bandwidths for different department. For the R&D department, at least they need to have 30 mega bandwidth, and production department, they need to have another 30 mega. And for the rest of the department, they can share those rest of the bandwidth, or this bandwidth can also be shared with all the departments. And basically, the departments will be differentiated based on the IP range, based on the IP address. We can set the address A. This address entry is for R&D, and address B is for the production. So in this case, we can configure the pipe that matching with different user IPs, and then assign for different bandwidths, and control for the bandwidth. And second requirement is the bandwidth control for the applications. So within the organization, you need to limit, or you need to control the P2P traffic to less than 10 mega. And under the P2P applications, actually, you also have some sub applications. For example, like P2P downloading and P2P online stream. So P2P downloading, we need to set no more than 2 mega, and P2P online video no more than 8 mega. So that is the control for the P2P traffic. Besides that, you also need to assure or make sure the bandwidth for the critical business service, including the web browsing service and also the email service. So bandwidth should be assured for each of the user to make sure all the user will have normal internet access. So we need to make sure the bandwidth for each user is no less than 500K. So based on the analysis of these two requirements, we need to use the two-dimensional QoS control. So the first level will be used to control the total bandwidth for different user group. And the level 2 QoS control need to be used to control the global applications and also the sub-application. In this case, let's have a look how to configure for the QoS. First of all, you need to add a root pipe. and then specify for the matching conditions, which is from trust zone to untrust, trust zone to untrust. And then you also need to add the subpipe under this root pipe. So one subpipe for R&D department, which we match with the address A as their IP address. And you also need to add another pipe for operation team, which is the address B. After that, we also need to add the action for both of the root pipe and also the subpipe. As you can see here, those we already configured one root pipe. As you can see here, this is the root pipe. So forward and backward, both the pipe bandwidth is 100 mega, which is the the link bandwidth for the entire pipe, And under this root pipe, we also add two subpipe. One is for R&D, and for both forward, backward, it's 20 mega for R&D, and also for production team, 30 mega. And because the rest of the traffic can be shared, so we also set the maximum bandwidth is 100. So this is the level 1 traffic control based on the IP address, based on users. You can also configure these through the command line interface. So the configuration steps is same as what you did through the web UI. So first of all, you need to configure the level 1 QoS to add the root pipe and also two subpipe. And after the level 1 control, we also need to configure for the level 2 control for the global applications. So first of all, we need to add for one root pipe, also match the traffic from inside to outside. So this is an overall traffic control from your internal organization to the internet. And after that, we need to configure for subpipe, for critical or for your normal business service, including the email and also the web browsing service. We also need to configure another subpipe under this root pipe for the applications that you want to do limitation. Which is the P2P applications. You can group all those P2P applications into this subpipe. And under this subpipe, you also need to do a nesting. You need to add another subpipe under this subpipe to do a fine-grained control for the sub applications. As you can see here, we need to add one subpipe for P2P downloading and another subpipe for online videos. After that, you will have the pipe configured as this. So this is the first layer, root pipe, and this second layer, subpipe, and this is the third layer, subpipe. And you can even add one more layer for the subpipe. As I mentioned, we support 4 layers nesting. So for the root pipe, as you can see here, we do the bandwidth reserve as 100 mega in total. And for those two subpipe, one is for critical business service. We need to make sure 500K per each of the user. And for the total bandwidth for P2P applications, which we need to set 10, no more than 10 mega as maximum. And also under the P2P, we also configure for the specific sub applications like P2P download no more than 2 mega and P2P online stream no more than 8 mega. So that is the level 1 control for the applications. This is the reference how to config for level 2 control through the pipe. As I mentioned, you need to add the root pipe at first, and then add the sub pipe. And also you can add multi-layer sub pipe to do the fine-grained control for the sub applications. And after you have configured all those pipes and also the configurations for the actions, the traffic that flows into the device will be classified into different pipe by matching with the pipe conditions and also controlled by the actions. And through the monitor, you are able to monitor the bandwidth for each of the pipe. As you can see here, we already configured for both level 1 and level 2. After that, you are able to monitor the traffic that pass through for different pipe. Here are some highlights for the root pipe features. As you can see, different root pipe, they are separate. They are separate channel for the traffic. So no bandwidth borrowing between the root pipes. They have their dedicated, reserved bandwidth. And there's one default root pipe predefined in system, as I mentioned, which is the default root pipe. And the Qos mode for this root pipe is statistic, which is the monitoring. So if no any traffic matched with your customized pipe, so the traffic will flow into the default root pipe for bi-directional for all directions. And only the root pipe can change the Qos mode, as I mentioned. Only the root pipe can change for the Qos mode. So Qos mode including shape, police, and also monitor. All the sub pipe they will follow the same Qos mode to control for the traffic transmission. And the last one, only the root pipe can configure for the whitelist. So you can add the whitelist into the root pipe. So the users that in the whitelist will not be controlled. And here are some common features for the pipe. One is priority. So you can set the priority for the pipe. And the smaller value is, the higher priority is. If you set a small value in one pipe, which has higher priority, so once the traffic flows into the device, the system will first deal with the traffic into this pipe. And you can set the priority for each of the pipe except the default pipe. So that is the sub pipe priority. Another one is the sequence. Number, which is used to adjust the matching sequence. As I mentioned, if you have multiple pipes that configured for same matching conditions. So the matching sequence will from the top list to the bottom, from the top list to the bottom. By default, they are in same sequence. Default, they are in same sequence. Or you can change. And here's the configuration for whitelist. You can set the whitelist and add it to the root pipe. So here are some questions for the QoS. So what are used as pipe filtering conditions? As I mentioned before, including both source, destination, IP, zone, services, users, applications, and also URL categories. What's the meaning of forward and backward traffic? So forward is the traffic from source to destination, and backward is the traffic that back from the destination to your source. How many layers of the pipe can be created under each QoS level? So for both QoS level 1 and level 2, under each level, you can have maximum 4 layers nesting, 4 layers pipe nesting. What are the supported QoS actions? So this is asking for the QoS mode. We support 3 QoS mode: shape, police, and monitor. Which 2 actions can be used to limit bandwidth? So shape and police, they can control for the traffic, but monitor will only monitor for the traffic without doing any control, without doing any traffic control. So this is the QoS part.